All right, in class today we were talking about multiplying radicals. Tonight we're going to talk about adding and subtracting radicals. So we're going to be able to add and subtract radicals. Okay, add and subtract radicals. So make sure that you are following along in your notes while I type on the screen. So when we were multiplying radicals, we followed a very different process than what we're going to follow now. So let's say, for example, I have 2 square root 6 plus 2 square root 24. Okay? So the first thing we have to do, step 1, is make sure radicands are the same. Okay, we call these like terms. Now, remember when I say radicands, I'm talking about the numbers underneath the radical symbol. Now, we're going to notice that currently the radicands are 6 and 24. 6 and 24 are definitely not the same number, so we're going to have to simplify. So step 2 is simplify radicals, and I'm just going to put a little square root symbol, okay? So let's start with 2 square root 6. So 2 square root 6, okay? So we need to figure out if we can simplify this. Remember, we do that by upside down division. So this 2 is going to hang out on the outside. We're going to do upside down division with 6. I look for prime factors. So 6 divided by 2 is 3. 3 divided by 3 is 1. And we always want to end with 1 when we do this. And I look at my prime factors, 2 and 3, and ask myself, can I find any groups of 2 of anything? Well, I've got a 2, I've got a 3. Neither of those are in a group of 2, so I can't take anything out of the radical. So this 2 on the outside, he stays on the outside. And then this 2 and 3, they just stay right underneath the radical, 2 times 3. And it really is not going to change at all. 2 root 6. Okay, so that sign's going to stay the same. Let's look at our next one. So we have 2 square root 24. Now I'm guessing we're going to be able to take some factors out of this. We're going to keep 2 in mind. That's going to come down at the very end. And let's do upside down division with 24. It's got a factor of 2 and 12, 2 and 6, 2 and 3, and then 3 and 1. Again, ending with 1. Okay. Let's look at our prime factors, 2, 2, 2, and 3. Since these are square roots, I'm looking for groups of 2, and we see that we have 2 2's. That's good. So a 2 is going to come to the outside. Don't forget about this 2 in the front. He's got to come down too, separated by multiplication. And then whatever's left over, this 2 and this 3, go underneath the radical symbol. So let's simplify this. 2 times 2 becomes 4, square root of 6. Now remember, this term, 2 square root 6, couldn't be simplified any further. Now let's look back up at the beginning and look at the operation in between the two, plus. So we're going to bring that down. Okay, so we've done step 1, we've done step 2. Now on to step 3. Now that we have like terms, so 6 and 6 underneath the radicand, we're going to keep the radicand and the radical symbol. So we're going to keep that square root of 6, and we're going to add or subtract the coefficients. Okay, let's give it a little bit more room. Now we can add or subtract the coefficients. So our coefficients, remember, are what's in front of each radicand. So we have 2 plus 4, so 2 plus 4 leaves us with 6 root 6. And there's our final answer. All right, let's try another example now. So let's start with something like this. I have negative 2 root 3 plus 3 root 27. And we're going to start with number 1. Make sure the radicands are the same. So let's identify the radicands. The radicands are 3 and 27. Those are definitely not the same. So we're going to have to move on to the next step, which is simplify each square root. So let's take a look at the first one, 2 square root 3. 2 square root 3, or negative 2 square root 3. The square root of 3, that's already a prime number. That can't be simplified any further. So cannot be simplified. So this is just going to remain the same. So I'm just going to kind of move this down a little bit. And negative 2 square root 3 is just going to remain the same, okay? Because it cannot be simplified. But if we look at this guy, 3 square root 27, this can definitely be simplified. We're going to keep in mind the 3 in the front and come back to that. And we're going to do upside down division with 27. 27 is divisible by 3. That's a factor of 9. 9 is divisible by 3. 9 divided by 3 is 9. And again, 3 divided by 3 is 1, ending with 1. Awesome. All right, let's take a look at our prime factors. 3, 3, and 3. This is a square root, so let's identify groups of 2 3s. Okay, let's simplify this. Those 3s, not a 2, it's a 3 is going to move down here. Okay, don't forget about the 3 at the very beginning. Can't forget about him. And then whatever was left over, this 3, goes underneath the radical symbol. Let's simplify this. So 3 times 3 gives us 9 root 3. And remember, there was addition in between the two examples. Okay, so now that we have like terms, or the similar radicand, we're going to move on to step 3. Keep the radicand and the square root symbol. So we're going to keep this square root of 3 for our answer. And then we're just going to add or subtract the coefficients. In this case, the coefficients are negative 2 plus 9, which gives us 7. So our final answer is 7 square root 3. Now, what happens if you had something that looked like this? 3 square root of 6 minus 4 square root of 6. So we're always looking at the radicands first, okay? So look at the radicands. Are they similar? Well, in the first example, the radicand is 6. In the second, the radicand is also 6. So that's good, okay? We're still going to ask ourselves, can we simplify? Can we simplify 3 square root 6? Well, we already saw in a previous example that when we factor 6 into prime factors, 2 and 3, 3 and 1, 2 and 3, we're not going to be able to get groups of anything. So anytime we have something like the square root of 6 like this, it cannot be simplified. Cannot be simplified. This cannot be simplified, and this cannot be simplified, okay? So all we have left to do is keep the radicand. So keep that square root symbol and the radicand with the like term. So square root of 6. And then our final step, just add or subtract the coefficients. And I'm just going to abbreviate that, okay? Add or subtract the coefficients. So our coefficients in this case, let's see, we had 3 minus 4. So what are we going to get with that? Well, 3 minus 4 is going to give us a negative 1. So you could see your answer written as negative 1 square root 6, but anytime you have a 1 coefficient, they're usually going to get rid of it for the identity property of multiplication. So it's probably just going to be written as negative square root of 6. So let's try one more where we have like radicands. So for this example, let's say I have negative 10 square root 7 plus 12 square root 7. Automatically, we should be noticing that the radicand, square root 7, are exactly the same, and the square root of 7 can't be simplified into any other prime factors. So our answer is going to have square root of 7. Next part is we're going to look at our coefficients. So negative 10 plus 12, and we're going to simplify that. What is negative 10 plus 12? Negative 10 plus 12 is just going to give us 2. So our final answer would be 2 root 7. All right, we're going to try one last example. So let's say I have, let's see, I'm going to have 3 square root of 3 minus the square root of 8 minus 2 square root 3. So notice this is a little bit different because we have 3 terms instead of 2. Let's check our radicands. I've got 3, 8, and 3. Automatically I notice that 8 is different, okay? So we can do a couple different things. What I would do first is try to simplify it, okay? 3 square root 3. Can this be simplified any further? Well, the square root of 3 is just going to be broken down into 3 and 1. So there's no groups that come out. It can't be simplified any further. So 3 square root 3 and negative 2 square root 3, these stay the same. They cannot be simplified, all right? However, the square root of 8 definitely can be simplified. So let's do that. Let's do our upside down division. Okay. We've got prime factors of 2. I've got a group of 2 2's, so we'll bring that down. 2 square root, there was one little 2 left over. Okay. And let's bring down the rest of our terms. And we're going to be very careful not to lose the operations in between them. So we're going to bring down a 3 root 3, and then there was a subtraction in between those. And then again, a subtraction in between that and the next term, 2 root 3. All right. So let's identify some like terms. I'm going to highlight them if they're like each other. Square root of 3, square root of 3. So these two we can combine, okay? I'm actually going to, I'll leave them right like that, but I know I'm going to have a square root of 3, and I'm going to simplify their coefficients. So we have a coefficient of 3 and minus 2. So let's simplify that. 3 minus 2 leaves us with 1. And then this guy right here, negative 2 square root 2, it doesn't have any other similar radicands, so it's just going to stay the same. You could leave this as your answer right here, or just like in the previous example, if you have a 1 coefficient, a lot of times that will just disappear. So you'll end up with the square root of 3 minus 2 square root of 2. These cannot be combined any further. Why do you think that is? It's because their radicands are totally different numbers. Okay, so since this radicand is a 3, this is a 2, and they cannot be simplified, that's it. That's our final answer. All right, I hope that helps. Make sure you take notes and try the next problems. Remember, problems are not graded, but I do look to see that you've completed the homework, so try your best.